Good morning and welcome to another data science lunch and learn. I have the entire, I believe the entire data science team. There are probably some other folks that are joining us. Shelby's telling me yes, this is the entire data science team. So excited for everyone to be joining us on May the 4th. Obviously a national and global holiday. May the 4th be with you, to all of you out there. We're all celebrating privately in our Star Wars gear. I may or may not have broken a lightsaber before we came on, that my daughter's going to be really happy about when she returns home. And cheers to all of my data science people. I could not think of a better Thursday than May the 4th with all of my nerds on the data science team. Today, we're going to be talking about scripting tiles versus Jupyter. And if you're new to data science tools or you want to be more familiar with what's available here with coding options, today is the day. So thank you for everybody joining us. Let us know where you're from. If you have any questions or comments, throw that into the chat, which will be on that side of the screen. Throw that into the comments section in the live chat. We'll be happy to interact with you throughout the show. Florencia, Brian, Steven, Shelby, Vishaka, Christy, all of us here at Domo are excited to provide this really cool presentation for you today. As usual, I will get out of the way, and I have been told we've got some new presenters today. So Flo, Christy, and Steven and myself will be now removing ourselves from the screen. Brian will be sharing his screen and presenting. Really excited for your team to be joining today. Thank you guys so much.
Fantastic. Thank you very much, Eddie. And like Eddie said, a very happy May 4th to you all. May the 4th be with you. We are, like he said, going to be talking about the scripting tiles versus Jupyter workspaces and how you can implement data science in Domo using both. So let's dive in, share this agenda. We're going to start out with an intro to the data science tools that we have available in Domo. Then we're going to give you an intro. Given that it is May the 4th, we will be using a Star Wars themed data set, kind of surrounding the planets that exist in the Star Wars galaxy. From there, we're going to build a correlation matrix in both tools, Jupyter Workspace and the Magic ETL scripting tiles. And then we will pass it over to Vishaka for a little bit more in-depth look at Jupyter Workspace uses. And we're going to demonstrate the use of an accelerator tool that our team has created called the Data Profiler that very quickly creates a lot of very useful cards for exploratory data analysis, is a huge time saver, and utilizes Jupyter Workspaces in Domo to do that. So let's dive in.
Brian.
Before you start. We will dive in there. I don't know how well you can see that, but I do have my Darth Vader Death Star thing going on here. We are big Star Wars fans here. And given that, we're going to start this off with an homage to the mini wipe transitions that George Lucas put into his movies. We'll start with a wipe transition right here for y'all. And this meme, as we know, Luke was handed a lightsaber, most dangerous weapon in the galaxy, and immediately pointed it at his face. So we're hoping today to give you a walkthrough through some of these tools, and in all of our lunch and learns that we get to host, we're hoping to give you a little bit more background on these tools so that you can use them properly, not put yourself in harm's way, and really enable you to succeed with Domo data science. So let's go. Right here, we've got a couple of the Domo data science tools. We're going to make this PowerPoint slide available to y'all, by the way. And you can see here that we have some links to support pages that you will be able to find a lot more information about these individual tools, as well as other aspects of Domo in. But let's start off really quickly. For data science, we have 4 main tools that are premium features that you can have turned on. That's the Magic ETL data science action tiles, AutoML, and the 2 that we'll be focusing on today, the Magic ETL scripting tiles and Jupyter Workspaces. So the scripting tiles and Jupyter Workspaces are both code-heavy tools that we have in Domo. With them, you're going to be able to use Python or R to script, and you can do data manipulation with those. You can run models and prepare models with those. We're going to go in depth on the differences between those. However, just as a sky-high view of that, with Magic ETL scripting tiles, you're able to use the scripting language inside Magic ETL as part of a pipeline for data manipulation and then modeling. So you're able to really use a lot of that no-code environment for the data manipulation, if you prefer doing that in those tiles in Magic ETL, and then incorporating the scripting tile either in Python or R to do some of that more advanced customizable work on your models. With Jupyter Workspaces, that's a very, very customizable environment where you're able to do a whole host of things. You're able to do visualizations inside Jupyter Workspaces. You're able to do data manipulation. You're able to do a lot of customization of your models in Jupyter Workspaces. And the way that we on our professional services team for data science here like to use these is pretty much in conjunction with each other. Jupyter Workspaces is, like I said, a very free environment. We're able to do a lot of things. So we often use that as a sandbox for development of our models and do a lot of the heavy coding work in there. And then once we've refined that and we've got a really clean script, we can either schedule that notebook to run, or we can, if we prefer, we can take that clean script, copy it into a scripting tile in Magic ETL, and we can use it as part of a data flow in Magic ETL that way. So really, there are a lot of ways you can mix and match with the scripting tiles and workspaces, and there are good uses for both of them. So that's why we really want to get in depth on both of those today and show you examples of using either one of those options. So as promised, we're going to be working on a Star Wars planets data set. May the 4th be with you again. You'll hear that a lot today. The reason that we focused on planets specifically is that there are a lot of aspects about planets that are going to be measured numerically. That's really helpful and important for setting up a correlation matrix as we're measuring numerical relationships between observations within a data set. So you can see here, this is just that regular data set environment within Domo. You've got the table where you're actually able to see all of your observations laid out in like a spreadsheet format. However, there's this second tab that we find super useful, and this is definitely a best practice with data management within Domo, is that you can come to this second tab. You'll have a list. You're probably familiar with this. You'll have a list of all of your columns here. And then you can actually write in a description for either all of your columns or specifically those that might be a little ambiguous and might bring questions. So for example, the diameter of a planet, that could be measured in miles, kilometers. It could be measured in inches for all we know. So we were able to go in here and you can edit that very easily and make that very clear for anybody that comes into your Domo warehouse for data. And that way they won't have to be sending emails over and over. They won't wonder. They'll be able to see, oh, this is the diameter of the planet in kilometers. So like I said, we've got a lot of different numeric measures in here. The rotation period of a planet, orbital period of a planet. A couple of the categoricals that we've included here are the climate of a planet and the terrain of a planet. Now, I'll show you later on, the climate was one that we ended up incorporating in the correlation matrix. The terrain was a little bit dirtier and more difficult to use, so we decided to leave that out of our correlation matrix. All right, and a little bit more homage to Star Wars here. You may recognize these planets, and
Brian, can you hear me?
Oh, I can hear you. Yes.
Sorry about that. We're getting nerdy in the crowd and in the chat, which I love. Also, for those that are curious at the beginning, I did manage to be able to fix the lightsaber during that short intermission while I was off screen. Boy, oh boy, that was a whirlwind of emotion for your host, as that's a prized possession of my daughter. So it is now fixed. But also for Michelle in our chat, does this data set include the Camino system? She's just curious. A very great Star Wars reference there. We encourage everyone watching, use the chat. Today's a fun day, right? use the live chat. Tell us where you're from, ask questions, get engaged with our presenters. That's why we're here, to help support. And if you've got something super nerdy or super specific, this team can help. So thanks everybody for joining again. We've got a huge crowd today, so want to make sure you're engaged in the chat and asking questions and getting the support you need. So thanks again, Brian. Appreciate you letting me jump in there. Michelle says if it's not in the records, then it does not exist. Michelle, she's probably on the dark. I feel like she's a dark side person, right? Like she is definitely a little dark there on these comments today, this morning. Yeah. I like it. Let's keep it going.
Michelle nailed that. Yeah, I'm not sure if it's in our data set because it may not be in the records. It was a hidden cloning planet that Cypher Diaz was able to strike a deal with, right? So yeah, I didn't check for Camino, but I did check for these planets here. I know that we've got these ones, and let me be clear for the really in-depth fans here, Endor is a moon. I realized that. So we've got some moons mixed in with our planets here, just to be clear. However, as you can see, that's no moon. We've got the Death Star here. And I don't know, does anybody feel a disturbance in the Force? As if millions of voices were crying out in terror? Because Alderaan is gone. Now, I didn't remove it from the data set. We're going to go through this as if Alderaan still existed. You know, the Darth Vader has not gone after it. The Death Star is not fully operational to this point, but just thought we had to work that in there. I couldn't help it. But very cool. Now that we've had a little bit of fun, let's get into the real fun, right? The data science side of this. So what I'm going to be presenting on is the Jupyter workspace side of things, and then I'll pass it over to Shelby. She'll be diving in on the scripting tiles. So to get access to Jupyter workspaces, like we said, it's a premium feature that you would have to have as an add-on. But to get to it, once you've got that add-on, it's going to be in the same data tab you're familiar with. And rather than looking in this data sets or data flow tab that you use most often, you'll come down to the ellipses, and it will show up down here with Jupyter workspaces. Again, if you don't see that, talk to your AE. You can work to get a deal there to get the Jupyter workspaces function turned on. Once you're in the Jupyter workspaces, it's going to list all of the workspaces that you and the rest of your team have created. Right here, I've got our previous Lunch and Learn listed and the Star Wars Planets one. And like you see in a lot of Domo, we've got a wrench here. This is going to indicate things that you can edit about the workspace. So I'll come in here. If I'm setting this up for the first time, then it's going to take me to this screen, and I can go in after that first time as well and edit it like I'm showing. So you'll give it a name. You'll give it a description for others. You can then move on to the configuration. So this is where you choose whether you're going to be coding in R or Python. So you choose one of those for the workspace that you build. And then there are compute tiers. So the higher the tier, the more computational force you're going to be using, the more resources you'll be using, and in turn, the more run credits you're going to be spending. So if it's not a very computationally intense code or project that you're running, I tend to keep it up here in these lower tiers, so it's a little bit less expensive on those resources. And this also goes in hand with that. If you're using something that's very low in resources or doesn't really require a ton of computational resources, you should keep that timeout at a lower setting as well. If you have something where you're running a model on a lot of data, something really complex, maybe a neural network, then maybe you want to run this timeout to a much higher so that it gives it time to run that. And then that compute tier might want to be a little bit higher as well.
Brian,
all right.
Question from our chat. Clifford here on YouTube. Appreciate you watching, Clifford. I love that. Can you create a way of auto running the Jupyter notebooks? The only way I can incorporate scheduled Python runs into my ETL is through the tile, but prefer notebook schedule instead. Curious if you guys have thoughts on that. I know that my background folks, unfortunately, we're having an issue with the chat today. Of course, why not? Let's just add to the list of things over here on the right-hand side on your live comment section. So I'm working diligently to try to figure out what that is, but we'll be copying and pasting answers from myself on the back end for that if our live hosts are a little bit stumped by this question, because I do think we have some answers on the back end there.
Perfect. Yeah. Thanks, Eddie. And thanks for bringing that to my attention. Yeah, Clifford, that is a fantastic question. And we actually do have a way to run those automatically. You can actually create a Jupyter workflow, very similar to the data flows that you create in Magic ETL. So that can be run to or scheduled to run on a daily basis, hourly basis. There's customization on that. And I can get into that once we dive into the Jupyter workspace itself. Just got a couple more things here to share on the setup of the workspace, and then I can actually lead off with that scheduled notebook so that you can see that, Clifford. So let's get through the last bit of this in the setup here. So we've got the input data sets here. That's going to be any data set that you have in your Domo warehouse. You're able to bring in as an input data set. So you just click this input data set. You're able to search that and find the one that you're interested in. Finally, an output data set. This is something that the Jupyter workspace and the code that you write, you can write a data frame back out to the Domo warehouse. So I'll click on that, and I've already set that up, but this is a little bit different. Since it doesn't exist yet in the Domo warehouse, you'll click output data set here, and then you actually name it exactly what you want that new data set to be named. And then you'll be able to then execute your code and write that data frame to the warehouse under the exact name that you write here. All right, so now that we've got that setup underway, like I said, let's jump in. We'll start off with that scheduled notebook for Clifford and everybody that's interested in that aspect of things. Given that this is like a one-time correlation matrix that we're running, we don't have a scheduled notebook for this specifically. But if you had a model like a regression that you wanted to run on live data maybe once a month or once a day or week, you could set that to run automatically. There's this button right up here at the top called Scheduled Notebook. And you can see when I hover over it, it says Data Flow. And you can see here, I'm going to name the data flow that's going to appear back in the warehouse under the Data Flows tab. I'll have the description option as well. And then I can trigger exactly when I want that to run, either manually or on a schedule. If I click on a schedule, this is where I can set that schedule exactly how I would like it to run.
So can I add that this is Domo Jupyter's best feature yet? I am a fan of this feature. It's made everyone's life so easy. Just wanted to add that.
Yeah, thanks, Vishaka. I agree. Yeah, no, it really simplifies things with model pipelines, right? Fantastic. So good deal. So now that we've looked at that scheduled notebook, let's dive in really quickly to building a correlation matrix in Jupyter workspaces. So you can see here, this is similar to other iterations of Jupyter. You can do markdown files so that you can really clearly notate your code here. So you put those comments and then can switch to markdown instead of code here. So that's really nice and helps me to organize my code. But now that we're in here, let's start off. So we're going to import that data set. We've got all of the packages that we want to import here. If there's a package that you'd like in Jupyter Workspace that is not here yet, says it's not installed, you can install most packages, almost any package in the Jupyter Workspace here. If you have issues with a particular package, please reach out to your AE and we can get that figured out. And here in this first part, I'm importing all the packages I need and getting the input data set there. You can see here we've got tabs, and this is the datasets tab, same icon you see in the warehouse. And I have my input data sets and output data sets. So I've got the code here to input that data set that we created in our setup for the workspace. However, to do that originally, you don't have to memorize the whole name of your data set. You don't have to memorize all this junk. You can just double click this input data set, and it actually will bring that in with that line of code specifically, so that you don't have to deal with that long process every single time you want to import something. Same goes for when you want to write this output data set at the end. I'll show you that when we're writing that out. But here we go. I've just imported that data set. I've taken a look at the first few observations. You can see Alderaan's still here. I did not delete it. We're good. And so we've got that data set in here. We've got a few things that we need to change about it before we can do a correlation matrix. So we need all of those numerics to be read in as actual numerics. So we do some manipulation to make sure that that works correctly. And then, like I said, with a correlation matrix, we're specifically going to work with numerics more than categoricals. So we need a way, if we're going to incorporate a categorical, to actually change that to a numeric column. So this climate column, we're going to do what's called one-hot encoding. The process of that is changing each of these categories into its own binary column of ones and zeros. If that particular observation is temperate, then it's going to be a 1. If it's not, then it's a 0. And we'll create individual columns for each of the categories in this climate categorical. Now, with that, you want to make sure that if you are one-hot encoding, that category does not have way too many categories within it. This climate one has somewhere around 5 or 6, so it doesn't create too many columns. But if you had hundreds of categories within climate, that would in turn create hundreds of binary columns, which would just be a mess. So that's why this climate one works pretty well for us. And this terrain one's a little messy. So we're going to go ahead and do the one-hot encoding here. Again, you can see it as a categorical here. And then in this new data set, we've switched that to binaries for each one of those categories. And that's, again, the process for one-hot encoding, switching your categorical variables into numerical variables. All right, now that we've done that, I thought it would be fun to add Earth to this data set, just so that we have it as a reference point. So you can see here that we've got that. We've added it into the data set, and now we're going to see a correlation matrix with the Star Wars galaxy along with Earth. So let's get into that part, the fun stuff. So right here, we've used some code and written some code so that we can actually visualize that in Jupyter Workspace. Like I said, in Jupyter Workspace, you can visualize things and do a lot of the exploratory data analysis on the fly. Whereas in the scripting tiles, it's a lot more of a, this is a clean snippet of code, and it's part of our pipeline within the Magic ETL. So again, this is more of a true sandbox and development space for R and Python code. So given that we've done this visualization here, the darker color, whether that's green or pink, the darker it is, the stronger the relationship in this correlation matrix. So we can see here that diameter is pretty strongly positively correlated with orbital period. Gravity is also another strong correlation with diameter. So we're seeing a couple of variables here that strongly correlate with diameter, which is exciting. When you have those stronger relationships, you can make stronger predictions based off of them. All right. So now that we've done that, we're going to format the correlation matrix so that it can be used in a Domo card. So to do that, we kind of want it to be this kind of setup right here, where we have the first variable in the matrix versus the second variable in the matrix, and then the numeric measurement of their correlation, or the correlation coefficient here. So this is a good structure to be able to put it into a Domo card. So we restructure it so that it looks like this, and then we output this data set into a Domo data set. By using this code here, again, you're going to reference and use the exact name of the data set that you want that written out to. And again, you don't have to write that out every single time. You can actually just double click this output data set and it will write that code for you. All right, so that's Jupyter Workspace. Now we're just going to dive in and look at the Domo cards you're able to build really quickly with that. You can see here that we've got a full correlation matrix in a Domo card. So getting that output data set and then putting it into this card is going to be a way that you can actually share this with other team members. You can share it with any stakeholders that are interested in seeing this in-depth information. You've already done that exploration for yourself in Jupyter Workspace, but this is a good way to display that information. And we can see again that diameter has some strong correlations. So if we were thinking about doing a regression, diameter has some pretty strong correlations and would be a good candidate as a target variable. So if we were looking at doing a regression, we might structure it like this and say, hey, the target feature is diameter. I want to see each variable and how it correlates directly with diameter. Just kind of clean up that clutter and see directly what we're looking at here. And this is a way that I can do that. All right. And that is all I have there on Jupyter Workspaces. So we'll pass it over to Shelby to get in depth on scripting tiles.
Thanks, Brian. Let me get my screen shared. Okay, just checking. Are you all seeing my Magic ETL data frame? Data flow?
Yep, the data flow just popped up.
Great.
Yes.
Okay. So as Brian said, I'm going to be transitioning to talking about how to use scripting tiles. And as Brian mentioned earlier, scripting tiles is a great way to do R or Python coding directly within your Magic ETL data flow. So unlike Jupyter, where you have to open Jupyter and go to this other program, scripting tiles can be used directly in your data flow where you're already doing all of your other data manipulation. So it makes doing code as well as no code, low code together very easy. And so to walk through how to use scripting tiles, I will be showing how to make a correlation matrix, very similar to what Brian just showed you in Jupyter. So here I've got my data flow open, and as you can see, I've already got my Star Wars planets data set loaded in. And then I've just chosen some columns that I'm interested looking at correlations with. Now, when I want to do the code to create my correlations, I will go over here in the left-hand side and click on the scripting tiles. As a reminder, these are a paid feature. So if you have access, you'll see them here under scripting. Today, I'll be doing the correlation matrix using Python code. So I'm going to choose the Python scripting tile. But if you were using the R language, you'd choose the R script tile. Very similar to any other tile, you just drag and drop and connect. And you'll notice when you click on the Python script, this code window pops up, and there's already some code in here, and that's just standard. Whenever you open a Python scripting tile, this will appear. And I'm going to quickly walk you through what this code says. As a disclaimer, if you're not into coding, don't really know how to do it, don't worry if you don't understand anything I'm about to say, because at the end of this, I'm going to give you the code that you can directly copy and paste into this screen right here. And then you can run a correlation matrix easily without really understanding the code at all. So hang in there with me. The first thing that the Python script says is that you need to import the Domo magic package into the script. What a package is it's code that someone has already written that enables you to do whatever you want. So in this case, the Domo magic package is what is reading in the data shown here. So when you have a scripting tile, the first thing you have to tell it is what data you want to use and that you're going to apply your code to. And it's already populated that the data that I want to use is from the choose columns command. And that's just saying use whatever data manipulation I have done up to the point of my tile. And so there we go. I've got my data read in. I am going to change the name of it real fast. This is just a minor thing. One thing I want to note is we want to do a correlation matrix, so I need to grab a package that will allow me to run a correlation matrix. And if you come over here on the right-hand side, there's a thing you can click on called packages. And Domo currently has in the hundreds of packages already built into the script that you can use. And so the one that I want is called pandas. It's the one that you use for statistics. And once I've inserted that package here, I've read in my data, then the third part in the script here is where you actually write your script, meaning code that you want to apply. So disclaimer, I've already typed up all my code right here. So I'm literally just going to copy and paste it into my script. So it's saying here, create some binary dummy variables, calculate correlations, and then at the very bottom of your script, what you always have to do is write to a data frame so it's available to the next action. And what that means is it's just telling the script that whatever you did with your code, now write that data to a data frame so you can move on and do whatever else you want in your data flow. I'm just going to quickly rename that here. Data flow. Now, what I would recommend is when you've got all your code in your script, don't just do like save and run. You want to check and make sure that your script is correct. And the way to do that is you can push run preview over here or run preview up at the top. And depending on how difficult or demanding your code is will depend on how long it takes to preview. The correlation matrix should only take about 5 to 10 seconds. Yay! So you see here that we've got green check marks. That means that the script ran correctly. There was no errors. And if I go over here and look at preview, I can see what my data output was from the code that I ran. And you'll see here I have variable 1, variable 2, and correlation. And what this is telling us is here's a list of all the variables that we then correlated with another variable, and this is the correlation that you got out of it. Brian set up a very similar data set in Jupyter. Now that that's done, you can do some other data manipulation to this data set if you want. If you just want to create a correlation matrix, you can hook up an output data set like you typically do, and then take this output data set and create a correlation matrix using the pivot table in Analyzer, which is what Brian walked you through. Now, there's two things that I want to note now that I've shown you how to use the scripting tile in Magic ETL. The first is, I know I just discussed a lot, and so if you want to have some reference material that you can review about how to use scripting tiles, we have created, let me pull it up, a very handy reference materials guide that goes along with this webinar today. And let's see, right here we've got help resources for Magic ETL scripting tiles. This will take you to all of the knowledge base articles we have about scripting tiles that you can reference and know more about how to use them. The second thing I want to point out is that also in this guide, I have provided instructions on where you can go to get the correlation code that I referenced that you can just plug right into your scripting tile and use. The data science team has made this available through the Domo App Store. And just really quickly, you can find the Domo App Store in your instance right here. Click on App Store, type in correlation, can't spell. You'll see this calculate correlations section. If you click on it, it provides more detailed instructions, pictures of what I just talked through. And most importantly, if you go here to the code, you can copy the code and then paste that directly into your scripting tile for future use. I do quickly want to note as well that we have other other code already available. If you go over here in the search apps section and you go to code block, I'll take this off. We already have other code that you can just drag and drop into a scripting tile. One that I want to point out that's really cool that I use all the time is this change letter case of column names. This is a script to standardize the column letters across all of the variables in your data set. I don't know about you, but when you merge and create data sets, oftentimes you'll have some columns that are all uppercase or column names that are all lowercase, and it just looks bad whenever you create tables. And so if you can standardize those lettercase very easily, it just makes things look nicer. So that's just another idea of another easy way to use scripting tiles if you're new to them. Before I turn it over to—
Hey, Shelby, sorry. Yeah. I always hate this. I'm going to remove Brian. Sorry, you're going to be removed for a second. I always hate doing that because then we can't see people's faces. Oh, no. Now the screen's gone. So now we can see everybody. Michelle asked during your session there, Shelby, can these same code blocks be used in Jupyter as well?
Great question. So the answer, as always, is depends.
So that answer.
In general, right? Like you can do R code in Python. In scripting tiles or in Jupyter. So in theory, you should be able just to drag and drop the code from one place to the other. As a fair warning, sometimes the way you load in packages can be a little bit different between Jupyter and scripting tiles. So sometimes it's just a bit buggy. That's my warning there. But in general, yes, you should be able to swap the code in and out from both places and it will run both places.
Perfect. Thank you.
Yeah. Before I turn it over to Vishaka to walk through the data profiler, I just quickly wanted to talk about when should you use scripting tiles versus Jupyter? Because as I said, you can code in both. And what we recommend as a data science team is for scripting tiles, we recommend you use scripting tiles when you have code that isn't very long and that you don't really need to iterate on. So a good example of that is the correlation matrix I just did. As you saw, the code was only a couple lines long. You don't have to tweak it much. You just paste it in. That's when we recommend using scripting tiles, as well as like the types of things we recommend using it for is very basic analyses like correlation matrices, calculating standard deviations, etc., as well as any kind of data transformations that you'd like to do. So an example of that would be like one-hot encoding where you're creating dummy variables, etc. So just anything kind of simple that doesn't take a lot of code is what we recommend. And now Vishaka will talk about when we recommend using Jupyter over the scripting tiles.
Thanks, Shelby. Okay, before I dive into all this stuff, a little quiz for you. I did attempt to dress up as a Star Wars character today. So help make me feel better. If you have any guesses, leave them in the chat, leave them in the comment. This is not a test for you. This is my test on how successful I was. Anyway, moving on. So as to add to what Shelby was saying, one other example of when Magic ETL scripting tile is better than the Jupyter notebook is, I think Brian and I believe worked on a use case very recently where I'm seeing comments there. Okay, I'll try not to get distracted by the comments.
Just ignore Mark Booth. He's like it's the troll that makes his way onto YouTube chat during obviously a global holiday that he doesn't. Surprised it wasn't a Star Trek reference, honestly. Really, really surprised at that. So glad he's joining us, and thanks for popping on, Mark. But Princess Leia is not the right answer. Clearly, the hair is a dead giveaway here. So anybody else in the comment section, again, Mark, he loves Star Trek. He's not a big Star Wars fan. So I don't know why I work for the guy, but here he is. So sorry about that, Vishaka. Anybody in the comments, please let Vishaka know, let her know who she is, right? There's a good one here.
Thank you.
Hair is a dead giveaway, obviously. Let's go. How about a clue? New movies, not old. How about that? There we go. I'll give a little clue there.
I won't be too depressed, so don't take this too seriously. So, all right. So, Brian and I recently worked on a project where we had to do loops And when you have to do loops, as always, like Shelby also said, you can do it in Jupyter versus scripting tiles. And in this specific use case, we had to calculate the value of the next cell or the next row based on the previous row. And while this can be done in either Jupyter or Magic ETL, in this specific use case, we thought it would be better done in Magic ETL because we wanted to keep all the transformations together. Yes, Mark, thank you. We wanted to do all the transformations together. It was a smaller chunk, so we thought it would best not to jump between Magic ETL and scripting tile and Jupyter workspace. So as in most cases, it depends on what works for you, what you want to keep together, what you want to branch out for. But there are some things that you can do in Jupyter that you cannot do in Magic ETL. So as an example, I will share my screen here. All right, so let's see. Okay, are you able to see my screen? Yes, perfect. So as an example, of course, I'm sharing the wrong things. Let's try this again. Okay, are you seeing my Jupyter screen now? Yay, okay. So in this example, you're seeing that as a data scientist, I wanted to do some modeling. So I jumped a bit. I have several notebooks here where I try different types of models on the same data set. And this is iterative. I want to try different things to see what works best. As part of my modeling, I also want to do some visualizations. Now, visualizations like these, custom visualizations like these, is something that you cannot do in Magic ETL. So this is a quick way to visualize your data. And then once you have a model that you like, that you want to use and want to promote to production or automation, that's when you kind of like finalize it and create a notebook and schedule it and automate it. So that's one use case. The other use case, I just realized in this tool I cannot share the entire browser. So pardon me while I stop sharing and share the next screen. All right, so then another thing that we use as data scientists, we oftentimes, as you probably know, you're not seeing my screen yet. There you go. Some of the things that you'll always do as data scientists is build a data profile. You look at histograms, you look at the distribution, you look at box plots, scatter plots, correlation matrices for every single use case or every single data set that you'll be working on. Now, that's a lot of repetitive work. So what we have done here is we have built something that we call an accelerator. And as part today, I think Shelby has already or will be sharing the resources where you can access the script here. But what we've done is automated all that. It's no fun to build hundreds of cards that you help you make do some analysis over and over again. So I'll give you a quick walkthrough of what this script is able to do. So when you're able to download the resource, it will come in a zip file. You extract it, you start a new workspace. Brian walked through that, and then upload all the files here. So this is the notebook that holds all the code. I'll go through this in a second here, but these have some documentation. And there is another README file in here. And as part of it, it describes what I'm going to describe here on how to use this tile. So this is a README file here. But to give you a quick overview, going back to the notebook here, you want to start by, I've already run some of the code here to kind of accelerate this demo, but you just run this first cell. It then pops up this little GUI here. Some of you have SSO enabled in your instance. You can choose what method of authentication you want to use, direct or SSO. In this case, I'm going to use direct. Pop in the name of your instance. your email and password. I logged in already. You don't want to see me type while people are watching. So and then I want to use the specific. You probably don't see it, but the data set that Brian has created for the Star Wars data set is what I have popped in here. The data set ID. If you in the browser, you'll see a combination of digits and alphabets. That's usually the data source ID. You pop that in here, and then you say login. You'll get a message, login successful, if you're able to successfully log in. And then you specify a page name. In this case, I started off wanting to analyze the Star Wars planets data set. So I popped in VS Star Wars planets data profile. I can click in everything that I want from as part of my analysis. So I will do correlation profile, histogram profile, and also in this data set, I want diameter is as the dependent variable. And the type of inference, so the column, the diameter column in this case is numeric, so I'll specify numeric. We'll focus on this part here. So I also would like to see the scatter profile, box plot, and let's ignore, I'll come back to the bias profile. This is mostly related to categorical or classification use cases. So I'll come back to this in a minute, and this is time series. So after having selected all this, I will say run profile. I did run it already so that we don't have to keep waiting to watch it run. And let's see, look at correlation. All right. While it's sharing there. This is the name of the file that I had specified here. You can see it here, and then so it create a name of the page. So it created that page. Under that page, it created the structure, exploratory data analysis that has a correlation matrix, some subpages that have histograms, scatter plots, and box plots, and this automated what Shelby and Brian described, right? Shelby did this in Magic ETL, Brian did this in Jupyter Workspace, and you can do it in either, but this is something that just happened in a click of a button with all the color coding, everything, and the filters here. In addition to that, it also created these histograms for every numeric variable. It created it created bar charts for categorical variables. It tells me how many nulls, what percent those nulls are in the data set. So it gives me a pretty good idea of how clean or how populated my data set is. Moving on to the scatter plots gives you, kind of what correlation, positive, negative, draws the regression line. And I think this is where, when I selected the outcome or the inference type, this is where it comes in handy. What it did is it created a scatter plot between your inference or your outcome variable and every other numeric variable. So this is where it's been used, that input there, and box plots. So this was the continuous variable or inference type. Now moving on, what I am going to do is I'm going to open that up in the same. So then I go back and let's see. Oh, I'll have to stop sharing and present again. Okay, cool. Then I'm going back here, and as it's loading there, what I'll do is I'll change some inputs in the data profiler. So I had, this is the login. I'll change the dataset ID to the other ID. So this time I want to show you an example of a classification type. So I will pop in a dataset that is more of a classification example, hit login again, it'll be successful. And then in this time, let's see if I can do that real quick here. And this time when I do that, I'll get a few different examples. All right, so here I am going to pull in. Oh. I want the slash there. Let's see. Yay. Okay. So I'm going to say bias profile or something here. I won't enter it. I've already created the page there. I again want the correlation profile. I want the histogram. This time, though, so you see after logging in, it pulled in all the columns from it and populated it. So this time I want to see whether, so this is, I think, a data set whether to predict whether or not an individual is a smoker or not. So this is a binary classification use case. So dependent variable is smoker, inference type is categorical, yes or no. I also want the scatter plot, box plot, and this is the bias profile. So in this case, what you tell the data set is the yes, that's positive label, meaning that is coded as 1. So this yes and no is more intuitive. Sometimes, it's a different word like complete, incomplete, or authorized, unauthorized. So you want to specify what you want to define as labeled 1 versus 0. So this is what it's asking you. Again, we'll save the time series for later. But I think in the time series example, which is not this example, but if you plug in a data set where you want to do time series, you can select what is the x-axis, what's the date axis, and it will run the time series example for you too. So what that then looks like is if I say run profiler, it will then pop up it'll pop up of something called a bias profile, which helps you look at whether one data set, whether the outcome is more biased towards a specific variable or not. So as an example here, all this was automatically created. I didn't create anything. You can see correlation matrix. There's a bias heat map here. And we also have a glossary. In the interest of time, I won't go into too details of what this is, but this explains all the things that this bias profile is doing. It's giving you several metrics that help evaluate your data set for bias in terms of one specific outcome versus the other. Is the data set have more rows or observations for positive label than a negative label and all that, which helps you, whether it's a data set that's going to be biased towards one outcome versus the other. That's in a nutshell is what that is. And then I talked about time series really briefly. And then if you want to do time series analysis, then it creates all these different, so based on the x-axis, it will plot every other numeric variable in here. Now the data set I used was one hot encoded, so it has a lot of things that you probably don't need. But this is a good example. So if your data set has different metrics, continuous metrics like sales, profit, quantity, whatever, I think this will help you quickly graph all that without having to build all of those cards, and you can filter down and look at the trends really quickly. So how does Jupyter Workspace help in this? With this accelerator, the Jupyter Workspace is able to call APIs, Domo APIs, that help create a lot of these cards pretty automatically, reduces your work. And it's not just this, you can build your own, you can call your own APIs, you can call your own external systems, you can pull in data, you can build your own connectors with Jupyter Workspaces too. So in that, it has more ability than Magic ETL does. So that's in a nutshell of what you can do in Magic ETL versus Jupyter Workspace. Thanks. Back to you, Shelby.
Yay. Thanks, Vishaka and Brian. That's all we have for the webinar today. So thank you to everyone for joining. I don't know if we have any last questions.
Yeah, I'm feverishly trying to. Technology is not working out today. Feverishly trying to get all the resources copy and pasted in the chat for everybody joining us. Had a little bit of issue trying to get some of the back end folks to be able to respond to some of these, but everybody has been fantastic. The questions have been great. We had an appearance by Mark Booth, Mark Snodgrass, Sione, Michelle. Just Clifford, guys, thank you for joining these live streams as always. Let me bring back some of the back end folks, Florencia, Stephen, Christy, for again this global holiday, May the 4th. Appreciate everything that Brian has presented on Shelby and Vishaka today. The data science team, as always, again, I couldn't imagine what this session would have been on May the 4th with anybody but a bunch of nerds like you guys. So I do appreciate you jumping on and doing this every first Thursday of the month. Just so happened to land on this joyous occasion today. So we really appreciate it. Thank you, Brian. Thank you, Shelby, Florencia, Stephen, and Christy on the back end. Really appreciate everybody being with us live on these Domo Lunch and Learns. A really exciting one next week as we have a brand new guest, and I'm going to keep it quiet. You'll be able to find those details in the community forum and events page later on today as we schedule next week's sessions. Thank you guys again so much for joining. Appreciate everybody being here. We'll see you on the next Domo Lunch and Learn right here on YouTube or wherever you find these videos. And hopefully it's on the community forums. Appreciate you guys. Thanks again.
Bye.
Bye, everyone.